Good morning, good evening, good afternoon, depending on where you are. Welcome to the session. My name is Sanjay Mishra. I am a Group PM Manager at Microsoft in the Azure SQL Database team. And it's my pleasure to bring you the topic today, the future of cloud relational databases. Let's start the day with a cricket match. How about that? And you may be surprised what type of match is this? Sachin Tendulkar, who is a world-renowned cricketer from India, retired cricketer from India, wearing a yellow jersey. Don't worry, this is a charity match. And my apologies to people who are not familiar with cricket. You can draw similar comparison with your favorite sport. This is actually a charity match that was played in Australia to raise funds for the bushfire victims. If you remember, last summer in Australia, there were a lot of damages done by bushfires. A lot of wildlife, a lot of homes, a lot of residences, a lot of property was damaged. So the cricket fraternity around the world, they got together to raise funds. This is what I'm going to show you a video is actually not from the match itself, but during the halftime of the match, Sachin Tendulkar, who was not playing in the match, just padded off to face some balls from Alice Perry, who is world's number one all-rounder in women's cricket. And so she'll be bowling a few balls to Sachin Tendulkar, and we'll see how it goes.
5.5 years since the great man's had a hit out in the middle, and he's facing Perry, steaming in.
Now, at this point, your guess, will this be a short pitch ball? Will this be a bouncer? Will this be a Yorker? Will this be a wide ball? Will this be on the off stump, leg stump? Will this be scored for 1 run, 2 runs, 4 runs, six? Will the batsman get out by bowled, by caught behind, by LBW, or any many other possibilities possible in this one single ball? So people around the world in the countries who allow betting in sports, they'll be betting. They'll be betting at this point, this moment of the match, of the ball. What will happen to this ball? And let's play through, see what happens to the ball. And they'll be betting millions of dollars in bets. They'll be placing lots of money on it. Thousands of people, millions of people betting concurrently in a fraction of a second. And by the time the ball is bowled, and whatever happens to the ball comes back. Let us see what happens.
Works it off the hip nicely. Oh, it's through the gap, and Tendulkar's away with the boundary.
That's a shot he plays very well. I think he played the leg glance better than anyone that's ever played.
And by the time the ball comes back to the field, the people who had put bet on their money has been settled. This is a charity match, so do not expecting too many bets or betting going on. But think of this scenario in a World Cup final. Millions of people around the world will be using your betting application, which probably you have developed, and betting a lot of money on this match. Not just the match, ball by ball. This is called spot betting. They're betting at a spot for a very specific scenario for all the possibilities. And as you can see, within a matter of seconds, everybody has got their money or lost their money. Uh, Now, to build a run an app like this, you need a database that can handle millions of concurrent transactions. We are talking about money changing hands here, so there better be high, strong transactional consistency. It better be no, never zero data loss, highly available, and it can provide all the security means that an application like this needs. What database will you use for this? Of course, Azure SQL database. Now, whether you are writing a betting application or you are writing an application for your hospital, a matter of life and death, or whether you are writing an application for your bank, or whether you are writing applications for education, no matter which field or which industry, which type of application are you building, Azure SQL database is a database for all seasons. And I'm going to show you through a few demos how many scenarios you can build with Azure SQL database. Now, before we get into the details, let's look into all the history of this one. I'll stop the video and I'll move on to the next slide. Yes. We'll talk about the beginning, where all this database history started. How was this came into life? Then we'll talk about the present, and we'll talk about a bit about the future. In terms of beginnings, this year 2020, it has been a very crazy year, very tough year for a lot of us. This year is also an interesting year because this year completes 50 years of the birth of relational databases. 50 years back in 1970, E.F. Codd, also known as Ted Codd, wrote a paper, a relational model of data for large shared data banks. And you will not believe how influential this paper has been. This has been the father of all the commercial relational databases you see in the world today. If it has been a while since you accessed this paper or read this paper, or if you have never read it before, I sincerely urge you to read this paper. It's a worth reading, and I'm providing a link you here. You should be able to get access to this. Now, since that day in 1970, over the years, many research happened in this area and many commercial databases came into existence. This is a picture of Jim Gray, a well-known researcher from IBM and then from Microsoft. And he writes in around 2002, this article he wrote is that this is a textbook example of research paying off. Uh, Ideas coming out of academic and industrial research has beared fruit for creating an industry of relational databases on which hundreds and thousands of applications are based on. And at that year, the year he wrote this was it was $14 billion industry. Now it is over 50 billion industry. And you can imagine all types of vendors, all types of companies, all types of applications are built on top of this. And those were the industry early beginnings and a huge commercial success. Through this commercial success, we have seen is that now the cloud has come into the picture, and we are seeing a strong growth continues. The question comes, why this database has been successful for 50 years? Why this technology has been so prevalent in every world? The main reason is that this is based on strong mathematical foundation. We don't have time to go through all these details today, but what I urge you to go look into some good reading on these things. Relational databases provide awesome logical and physical data independence. This is very important for any database system to be successful, to be long lived. And you see, it's also based on strong foundation like relational algebra and relational calculus. And over the period of 50 years, there have been thousands of research papers that has enhanced from the early vision that EF Cord has, and now it has grown by leaps and bounds. And what is happening in the present? From those from the time of the research paper over through the ages, you have seen many highly commercially successful relational databases has come into the picture. SQL Server is one of them, which has been ruling for last 25 years or more. Now, in last 10 years or so, cloud databases have come into the picture. And today, what we want to talk to about to you is the journey to the cloud, how databases have made their journey to the cloud, how a cloud databases has grown, and some trends and some challenges facing this technology today. Uh, for the rest of the session, we'll be using Azure SQL database as our example, and we'll show you several demos how Azure SQL database is rising to the challenge of modern applications to win the world. The beginnings of Azure SQL database started in 2009, and at that time, one database could be only 10 gigabytes. Fast forward to 2019, in 10 years' time, we have been able to make a database up to 100 terabyte size you can have. And through these years, not only the size of the database has increased, but capabilities have increased dramatically. To start with, in 2009, we had a project called CloudDB. That's how the cloud journey for Azure SQL database started. And then we introduced around 2012, we introduced something called Sterling, which allowed the newer type of databases being created in Azure SQL database. And then we introduced Elastic Pools. The code name for that was Malmo. We introduced somewhere between 2015 and 2016. And then Recently, we came up with serverless, and we also came up with Socrates, which is also known as hyperscale. So these capabilities have come over periods of time, having strengthened Azure SQL database and its foundations. What's happening today? The challenge, what is happening today because of the cloud and because of the growth of the data, what we see is that complexity of application has grown. And the today's application not just need rows and columns, they need multi-model access to the data. They want to build graphs within the data. They want to build key value stores with the data. They want to handle JSON inside your database. So we will look today how is Azure SQL database rising to the challenges. And during this time, some new types of databases have also come into the picture, and some myths have been rising around Azure SQL database or other relational databases too. One of the myths that we are going to bust today is Azure SQL DB can't handle JSON data. And let's look at a demo and try to bust that myth. Okay. What you're seeing, we'll see here today is a Azure Data Studio. And in Azure Data Studio, we are going to query relational data and JSON data, and we'll show how to convert from one to another. Okay. This is a very simple example. It's a query in Azure Data Studio. If I do a select top three, I'm trying to select three rows from this table, and what I get is here. No surprise there. However, Azure SQL database comes with this new clause called for JSON path, which means that as an output of this, you will actually get a JSON, and each row will be represented within in JSON way. Let's see how it does. See, now what we see is actually JSON file, and you can do whatever you want to do with JSON. So if your application wants to deal with the data which is in JSON format, here is how you do it. Now this is we converted an existing row and column to JSON format. How about if we are given a JSON, how can we convert that into rows and columns? Let's look at our second query. What I have here is I have been given a JSON. I have been given a JSON which is in as you can see, this is in this format. Now my goal is to return rows and columns out of it. If I could do that just plainly by select star from OpenJSON. OpenJSON is a function provided by Azure SQL to convert from open a JSON and then convert to whatever way you want it to be. Now this will give us this with clause where we are going to pick up each of the JSON construct and convert them into a column, and then the whole thing will be a number of rows and column depending on how many JSON documents I have here. So executing this, what you get back from the JSON that was given to you, actually two rows and the columns numbered. So you got back rows and columns from JSON. So Azure SQL is very capable of handling JSON data. Now that we have burst this myth, let's look at what kind of uh, uh, products we have. As we saw, you have OpenJSON and ForJSON, two main most important components of Azure SQL database to handle JSON data, and we just saw the demo about it as well. Okay, where is JSON very useful? In today's world, with microservices, you see the uh, microservices and application talk to each other using APIs. If you're building APIs and want to communicate them with JSON, converting data into JSON and taking JSON data and converting into rows and columns is very helpful. Here is a GitHub project and a blog by my colleague David A. Mori. I welcome you to go through this. And actually, David also has a session in this event, so you should also look into that event, and you will see how JSON is so powerful and useful with respect to a relational database. Let's break the second myth. Another myth that comes around SQL DB that It is a relational database and it cannot handle graph workload. Modern workload is coming a lot with graph, and people want to build relationship. People want to find connection between various objects within their data. Now, can Azure SQL database handle graph? Of course. I'm providing you a few links where you should look at some samples and some concepts and architecture behind it. But how about we take a look at a demo and figure out how graph data is handled within Azure SQL database. To do this, I will use Azure SQL Management Studio, but before that, we need some data. To get the data, what we have here is some of you are familiar with Yelp, the website, which allows people to get various information about many businesses, and it also allows them to leave comments there. Yelp has provided for academic and for educational purposes a data set. This data set is real data, but this has been obfuscated by replacing actual people or actual businesses by GUIDs. So there is no PII information there, so anybody can use and play with them. My colleague Arvind has put together a GitHub project, so I welcome you to go through this project, and many way to capture this data, load this data into a relational table, and play with this data is given here. We're going to use some parts of this project today, and I'll showcase you some graph capabilities in Azure SQL database and a few more. Uh, in graph, what you'll see that the data provided by Yelp is actually in JSON format. So first what we need to do is that read that data from JSON and load into Azure SQL database. And this is how you do it. It's very, very simple. As I was showing you OpenJSON in a simple example, you actually do that. You do OpenJSON and then you provide what attributes you want to be converted into what columns. And ultimately then you put that into a actual table. And in the interest of time, I've actually run this and I've actually loaded data into the Azure SQL database. So I'm not going to load the data now, but you see, using this example, you can actually load the data. Now, once the data comes into Azure SQL database, you want to convert this into graph format, and you want to do some graph algorithms. A very popular graph algorithm is to find, are two people connected? You want to find out if I'm connected to somebody else, if X is connected to Y, if I, and the X and Y could be two people, it could be two businesses, it could be one person, another business, in many different ways. So what we are trying to find out here is that the two entities given to us, and as I was telling you, this data has been PII data has been transformed into GUID, so that we can all freely use them. And the two entities we have today are the two GUID I have here, and we are trying to find out, is there a relationship between these two GUIDs? So the algorithm that we need to use here is called let's find a path between these two entities. Finding a path between entities is a graph problem, and this is a brute force way to find out the connection between two entities. It is a very complex query, as you can see, it is a union all of many queries. It's a brute force way. We're going through hop by hop. You are trying to see, am I connected to one person and then to another person, then another person. This is not a very efficient way to run a graph query, shortest path query. So what we have done in SQL Server 2019 and the recent Azure SQL database, we introduced an algorithm called shortest path. This is provided as a function within within Azure SQL database. So what we are going to use is that we are going to use this shortest path, which allows us to for the query to be very crisp and easy to read and easy to understand. At the same time, this is also a very efficient algorithm to find shortest path. And let us see. This should come back in a few seconds time and it will tell us, yes, these two people are related by one hop. You can see that this is the starting person, this is the end person that we wanted to reach, and this is the in between person through which they're friends. So this is a very important graph functionality, and you can use them with Azure SQL DB provided graph constructs, nodes and edges, as well as graph algorithms like shortest path. Now, I'm not satisfied just by finding out if two people are related. So let's try to simulate a more complex scenario. We talked about cricket. Now it's time to talk about a bit about American football. A few years back, there was a American Super Bowl final, and that final was held in Phoenix Stadium, also called University of Phoenix Stadium or State Farm Stadium. And I wanted to go and watch the game there. So I'm trying to find out here that if I go and watch the game there, can I get any food nearby? Is there a restaurant nearby? Is there a business that deals with food so that I don't go hungry? So I could either eat before the game or after the game. Now, the important thing that I'm trying to stress here is that you can do spatial query, geospatial queries within Azure SQL database. You got the same data we loaded from Yelp. I don't have to move the data to another store to do graph or to yet another store to geospatial. All within the same Azure SQL database, you can do graph. You can also do spatial. And what I'm trying to find out that here is the geography of coordinates of the stadium within 5 miles. 5 miles converted to yards and feet, and so that the units match. And I'm trying to find out is the business category is food. So let's run the query and let's try to find out if there is any food related business within 5 miles of radius. And the geospatial query will come back in a few seconds, and I see that there is a bunch of those. So I'm not worried. I will not go hungry. And you can actually see these in a special output. Let me enlarge it. So you can see a few dots here, uh, and some dots here, some dots here. So these each dot represents one business or one row that that is that satisfies this query. So I'm satisfied. I am happy that there is a food related business nearby, so I will not go hungry. But guess what? I don't live in Phoenix. So if I go to Phoenix, I need to stay there somewhere. So I'm trying to find out, is there a hotel nearby where I can actually spend the night? So I'm going to find out. I'm going to use the same technique. I'm going to use this geography and coordinates of the Phoenix Stadium. And instead of finding a food, I'm trying to find hotels. And the rest of the query is all the same. So let's just do that. And there you go. There are tons of hotels nearby the stadium. And again, I could find them through the in my special graph. And you can see there are here, there are a bunch here, there is one here too. So there is one here as well. So there are lots of hotels nearby for me to spend the night. However, I'm not sure if I want to stay in just any hotel. I would like to see if these hotels are of my choice. And how do I find that? I like Residence Inn. I would like to stay in a Residence Inn, but I do not know how good is this specific Residence Inn. My way to find out if this specific Residence Inn is good is that I want to find if anybody in my network has stayed in this hotel and left a comment about this hotel. That will satisfy me that, oh, this is good. So I'm going to invoke graph to invoke my network, anybody in my network that I'm going to find through graph algorithm, and then I'm going to look into the reviews for this geography to find out if anybody has stayed there and left a comment. If any one of them have left a comment, I'm happy. So and that would satisfy me that okay, I can stay in the hotel. So imagine this is a fairly involved query, because what we are trying to find out this we are trying to find out um, a graph construct, and also we are also querying a geography construct. Let's do that. And this is a very complex query. As you can see, we are merging graph concepts, we're merging regular SQL query, and then also we're looking for a particular geography where we are trying to find information about. This takes a few seconds for to come back. You see, in 19 seconds, I could find out that yes, there is a person who is in my friend's network and has stayed in this hotel and actually left a comment. So that satisfies me, which means that I can go and stay in the residence inn. What we saw today here is that you can use a relational database like Azure SQL database and do complex graph algorithm like finding shortest path. You can also do geospatial queries, finding coordinates and finding businesses within a given coordinates. And you can also combine them to make very good use of your data to give you really intelligent information. So that's the power of Azure SQL database. You don't have to move the data to anywhere else to get this kind of information over there. This information about your businesses, about your customers, about their comments is already in your operational database, which is Azure SQL database. Why move it to somewhere else to do special queries like graph or geospatial? That's the power. Now that we have debunked that myth as well, let's see who is actually using it. There are tons of customers who are using Azure SQL database today, graph capabilities of Azure SQL database today, and one of them is BKW. BKW is an energy provider in Switzerland, and they use Azure SQL DB graph capabilities here to find out how to give the best connection to their customer in case there is a storm. They are finding out the shortest path to provide electric connectivity to the residences. In case some transformer is broken, in case of some lines are fallen because of storm or because of wind, they are trying to find out using Azure SQL Graph the shortest way to reach to their customers. So they've been able to improve their customer service using Azure SQL Graph. Moving on, another type we see today is a key value store. Now, people have been using very special purpose database to do key value store. We try to take a crack. Can I store? Can I use Azure SQL database to do key value store? Let's take an example. And to this demo, we are going to use a workload called YCSB. It's a workload provided by Yahoo. It's called a key value store benchmark from Yahoo that you can download and you can test it out. We have played it out here, and I'm going to run that workload to show you how we can scale it. Okay. This is invoking the workload, and this will be doing lots of operations on the key value store in a very concurrent way. And to show how much concurrency we are going through, I'm showing you a dashboard. This dashboard is built in Telegraph and Grafana. Uh, During the DPS, my colleagues Balmukund and Dimitri are actually giving a presentation on monitoring Azure SQL database, and in that they are also showing you how to build this dashboard. So I encourage you to go attend that session as well. And now look at this here. This is showing the batch requests per second. SQL users are very familiar with this. And to show you how many we are able to do that, if you can see, we are actually able to do um, uh, a very high amount of batch requests per second. Uh, for a very small capacity database, we're able to do more than 5,000 batch requests per second. And this is actually, as you can see, this is only a 4-core server. Our Azure SQL database is running on only 4 cores. And it's a general purpose tier, which is budget friendly and which is optimized for cost, not optimized for performance. Even with this kind of database, we're able to achieve more than 5,000 operations per second. Now, how many operations are I going to do if I scale these databases to better capabilities? For example, I could use a business critical database. I could use um, high memory SKU of the database. Uh, right now, this data is stored in a regular table. I could store the table in a memory optimized table. If I do all those optimization, I can actually scale my operations per second for a key value store to a very large number. For example, from 5,000, this is the example that we saw with a business critical 128 V core. If you really want, if you really need, and you can actually go 97,000 operations per second on a key value store. So what we prove here today is that you can achieve very high throughput, at very low latency, even for a key value store in Azure SQL database. Now, with so many great capabilities, no wonder Azure SQL DB is the best database for developers. If you're building a new application, either for your existing portfolio or for completely from scratch, look no further than Azure SQL database, because Azure SQL database is a database with batteries included. I like to give this example. Let's say you buy a toy, your favorite toy you bought, either you ordered online or you just got from a store, and it comes to your home and you open to assemble it to play with it. It says this needs two AA batteries and battery is not included. You cannot do any fun with that toy. So either you have to go find batteries somewhere, go to the store again, or order somewhere, wait for your batteries to arrive, and only then you can make the toy usable. It's not like Azure SQL database. The moment you provision a database, everything, all capabilities, whether these capabilities are about the product capabilities or these capabilities are about the infrastructure, they're all come packaged with you. You get packaged high availability. You get packaged with one click. You can do disaster recovery. All the backups are taken care for you. Patching, all maintenance, everything is taken care for you. All you think about, focus about it do is focus on how to write the best application. Now, developers like them because you can build with any development language of your choice, whether you are using Python or Go or .NET or C Sharp or Java. You pick your code. And once you write the code in Azure SQL database, you can actually deploy anywhere. You could deploy even in on-premises. The same code will run. You can actually deploy in a VM and that same code will run. You could deploy it with managed instance and the same application code will run. You could, as we saw, you could go JSON graph, all kind of modern application data constructs you can use within Azure SQL database. Azure SQL database also comes with built-in security for encryption, for masking, for row-level security. Uh, Depending on the type of application you are writing, you don't have to worry about, okay, now that I have written my app, how do I take care of all these fundamental needs? They all come packaged with you, and many more. And no wonder we see a lots of SaaS provider, which is a modern day trend today. Applications are now built and provided as a service. So it's called software as a service, application as a service to the whole wide world. And the people are using this because they find this Azure SQL database as a very effective database. For all the good things that we saw about application developer, it comes with a few more tools also. For example, you want to package a bunch of your customers into a set of databases and put them together in elastic pool for cost effectiveness, you can do that. Your database in deployment does not run 24 by 7. That means sometimes it is idle. Why waste money on an idle database? Use serverless. And we have many intelligent SaaS providers running on Azure SQL database today. And iCertis is one of those examples. iCertis is built on Azure SQL database and they are ready to deploy in any model in anywhere you want. As you can see, they do over 6.5 million contract across 90 plus countries. This data is slightly old. Today they will be doing much more than that actually. And all of this is done in Azure SQL database. Once the app is built in Azure SQL database, sometimes iService customers think that, oh, we need to deploy this in a managed instance because we want to control the VNet around it. Go ahead. Same application, same database logic will work there. Some customers want to deploy it in a VM. Go ahead, do that. Deploy that in a SQL server running in a VM. Same application code, same database code will work in a VM too. I want to deploy in serverless mode. I want to deploy in elastic pools. go ahead and do that. This is like write your code once and deploy anywhere flexibility. Gives the power to SaaS providers like Isotis to bank, to bet their business on Azure SQL database. We actually have a customer story written about Isotis. I encourage you to go and read that. Um, Now, going forward, what we are seeing is along with the application complexity, along with the need for multi-model data access, the scale is increasing. The scale is now not in thousands or hundreds. The scales are about millions of users, millions of devices, millions of functionalities to provide them. And one of them is IoT workload, where you have millions of devices sending millions of information to the database. And how can database handle? A typical myth that has come to surround Azure SQL database is that it's not good for IoT workload. You probably need a NoSQL database for IoT workload. That is not right. Azure SQL database can handle IoT workload very, very well. We'll show you today. Uh, this is a typical architecture of an IoT workload. You have a set of sensors and devices which is sending data through a cloud gateway, through some stream processing and or batch processing to some kind of storage. And when you represent this with Azure SQL database, the architecture will look like this. These are IoT devices sending through cloud gateway, either through some Azure functions or through stream processing to a warm data store and then to the cold path. Is Azure SQL database is a hot or warm path data store for Azure SQL database. For today, we'll talk about this path where data is coming into Azure SQL database. My colleague Silvano, who is also presenting at DPS, has written an excellent article with very, very detailed about how to build an IoT application with Azure SQL database. And these pictures are from that article. So I encourage you to follow the link and read the full article. We will take a look at it, this through a demo. We also have a video online for this specific workload that you can see here as well. What we have here actually is what you see is on a map, and these red dots are actually smart power meters. These are electric meters put on businesses, in residences, in various buildings, which are reading electric consumption data and sending it to a central database, which is Azure SQL database. And there are thousands of these, sending tons of data to Azure SQL database. Let's see how Azure SQL can scale. Okay, what I have here is actually a console application. When I start this application, this is going to actually simulate thousands of sensors, and they will simultaneously keep sending data to Azure SQL database. And what we'll see here is a graph of how many rows are coming into the Azure SQL database. Let's see. Okay, it's starting cold, and as you can see, it ramps up very fast. Several thousand, million, 2 million, 2.5 million, 3 million. These many rows are being inserted every second into a single database. So just take that into, let this sink in for a moment. 3 plus million rows being inserted every second into a database, and database able to handle that high concurrency with extreme low latency for the insertion. As you can see, it is going close to 4, it's beyond 4 million now. Now, how is this possible? How are we making able to make this possible? Let's take a look at the database, and you can see this today. We're going to take a look at this DMV, which can show us how is the resource consumption going on. You can see we're pushing the CPU very, very hard. 90%, over 90%. That's good. We're able to make use of all the resources in the database, not blocked by any other constraint, and being able to push the database to achieve a very high throughput. Is running well beyond 4 million now. Now, how are we able to do that? Behind the scene, what we have today is actually a SQL Server in-memory OLTP table, a table that entirely resides in memory. And you can see that with memory optimized on, this means it's a memory optimized table, and durability schema only, that means it is a table that is non-durable table. That means we are not writing to the disk, and therefore we are able to sustain such a high insertion rate at very low latency. The in-memory table is hash organized, and therefore no locking, no latching, straightaway very fast, extremely low latency, high concurrency ingestion is happening. However, there is a limit of how much memory a machine can have, how much memory a database can have, and therefore we may run out of memory very soon. So what we are doing behind the scene, we have a stored procedure which goes, takes this data out of this in-memory table and puts this into a table which is indexed with a cluster column store index. The cluster column store index is being able to handle the data loading into a column store index table is pretty fast. And let's see how this is organized. And this is organized as a create cluster column store index. Because this is a column store index, the storage footprint is small, very optimized. Moreover, when you want to read this data, this is also pretty fast because this is you need lot less I/O to satisfy your query. And also insertion into a column store will generate lot less log for this to continue. And you can see that we are continuing, going way beyond 4 million rows being inserted per second. Now, uh, we prove you that we can get a very high rate of IoT ingestion into Azure SQL database. But how about I want to consume this data? Because I want to read this data to figure out how much did I get any faulty measurement? Does this data look anything wrong? Or am I not getting data from a particular meter for some time, which means that maybe that meter is faulty? uh, all these kind of queries could come to an operational manager who is managing this power station. Now, to do that, what I also have is actually an application which is a very similar one. What this application is going to do is going to start a similar client application and then and then try to read data from here. Uh, Now, before I start this, let me show you the resource consumption, which is interesting for us. As you can see, we're pushing the CPU very hard, which means that if I start reading this data using my read application, this is going to put uh, a lot of load on my database, which it may not be able to handle. So how do I do it? Let me start and then explain. So we are now reading data from this database. And as you can see, after as it ramped up, thousands and thousands of rows, we are able to read it every second from the database. What we have here is actually a read-only secondary for this database. This is a business critical database, which means it comes with a free readable replica. You can put your application connection string with a phrase called application intent equal to read only, which is very popular. You already probably know it. And once you do that, Azure SQL database automatically redirect those connection to the readable replica. And all your read queries will start going to that replica. As you can see, while I'm doing ingestion at over 4 million without blinking an eye, I'm also able to read several thousand, 100,000, 800,000 rows per second from a copy of this database without wasting any resources or without causing any more burden to my insertion part of the application. So this gives you an awesome package to build IoT applications with Azure SQL database. Okay. And this architecture is actually called a shock absorber architecture, where the data is coming into a memory optimized table and then being pumped from the memory optimized table to a column store table. It's a very popular architecture with IoT workloads. And who is using it? This is an interesting use case here. RXR Realty is a company in New York City, and they own many high important real estate properties there. And they started as smart office uh, application post COVID situation. After the COVID lockdown started to reopen slowly and slowly, they have set up this smart office application all over the places, which comprises of uh, the IP cameras, thermal cameras, and various devices all over the places in all the buildings they own, so that anybody coming in, it will take a temperature measurement, and the temperature will be sent to the database. It will take a picture of the people. It will also manage the see how many people are already in the building, because the buildings were not reopened for full capacity. Maybe only 50% people can come in. From various cameras, it can actually calculate, okay, this building is already getting 50% full. I'm not going to allow anybody else. Or this person coming in has a high temperature, the gate will not work for them. To do this, they have established these kind of IoT devices, and this data goes into Azure SQL database as their warm store. And using various machine learning and cognitive services capabilities on Azure, they built a very intelligent system for smart office reopening. Actually, I have provided here is a link to an article and a video and how this company is able to manage this. Please go ahead and read those. Now, what we need to see, what the present telling us about the future. What we are observing today is that the data growth is exponential. In fact, 90% of all data that exists in the world today was created in last 2 years. Imagine what will happen in next 2 years and next 2 years and so on. Uh, with this exponential increase in the data explosion, we need to rethink how databases are designed, how databases are operated, especially in the cloud today. And you are seeing in cloud types of application that has come in which never existed before. So do this, we did a rethink about how we should rethink about Azure SQL database. This is a typical picture of any database. So in this example, let's take a Azure SQL database. One database is actually this. What you have is a compute node where you have database engine running, and the same either a VM or a container, whatever you want to call it, is the boundary. That's where your data files are, transaction log, temp TV, everything is within that. So you are limited by how much of SSD you can pack into one machine, and that limits the size of database that you can handle. As much amount of memory or as much amount of CPU you can pack into one machine or one container or one VM, that limits the capacity of your compute growth. So to break this apart, what we did was that let's redesign the back end of the database completely from scratch. So what we did, we took out the data files, put them in Azure storage, which is good thing. That means Azure storage is like a limitless storage. You can grow your data files as much as you want. So data growth limitation is relieved. However, because this is a remote storage, the performance may not be as great as you expect. So how do we compensate for that? In between, we introduced a set of caching layer called page servers. Page servers is actually a set of machine which is full of SSD cache, and the entire database is actually taken from the Azure storage, copied from here, and put in this SSD cache, all of it. Even if you have a 100 terabyte database, this caching layer will be 100 terabyte all on SSD storage, and that gives you awesome performance. Now, then the next thing we looked at, let's look at transaction log, and then we move transaction log to another service. In cloud, you build application using microservices. So page service is one microservice, log service is another microservice, and they're talking to each other in a very coherent manner, thereby allowing you to independently grow compute and storage. Now, now that we moved data files and transaction log from our compute node, we freed up a lot of SSD space on our compute node. So what do we do with that? We provide you another cache, and this cache is called a resilient buffer pool extension cache, and this is in the compute node to give you even better performance. So you can see from the application point of view, there is 3 layers of memory hierarchy: the buffer pool, which is the main memory, RBPX data cache, which is SSD within the same compute node, and then on another set of machines, you have an entire database cached in SSD cache, and below that is the durable data files on Azure storage. This together gives you an awesome cloud native design for database to scale for the present and for the future. So the real diagram looks like this. We have data files, you have many data files, and actually we take snapshot of the data files for backups. And then this is the page server cache. This is how it looks like inside. And This is how the log service looks like. And then we have a primary node serving the read-write application. And then you can actually have multiple secondary nodes for read-only applications, and you can access them through application intent equal read-only, like the example we saw a little while back. Now, putting this all together, we provide you a database architecture that we call hyperscale. SQL hyperscale can scale up to 100 terabyte of data. It can scale compute and storage independently. It provides you very fast backup and restore because we use snapshots for backup and restore, not regular SQL Server backups. Moreover, scaling the compute, if you want to go from 4 cores to 80 cores, is very fast because we don't have to move data to do that. Um, Starting up a new secondary, you can have up from 0 secondaries to 4 secondaries. Let's say you start with 0 secondary, then you say, okay, I want to add another secondary, or I have only 1 secondary, I want to add one more secondary. So scaling out to add more secondary is also very fast because we do not have to copy or move data to give you a new secondary. These capabilities provide this ready for all modern applications in cloud. Now, a myth that starts surrounding, oh, okay, it's a relational database and it can handle a lot of many small transactions, OLTP transactions that we know, but can it handle large transactions, especially if I make a mistake and if I break it? Now, let's go and then take an example. And this demo is called the killer. This Through this demo, we're going to show you, we're going to kill some sessions and see that. Let's go here and login time. Okay, I have uh, two SQL Server Management Studio windows side by side. I'm going to start a transaction here, and then I'll come back and explain what it is. Okay, need to reestablish connection. Okay, it's executing, and then let's do the same on this side as well. Okay, reestablish connection, and that's okay. Okay, now that something is started, let me explain to you. I have two management studio, each connected to a hyperscale database, and they're identical databases. They're exactly the same data, exactly the same size, except one difference. The difference is that they're each of these two databases are um, 13 terabyte in size, significantly big, and we are going to work on a table called store returns, which has 20 billion rows. The same table on each side, 20 billion rows. The difference between these two databases is this. It's called accelerated database recovery on. If it is 0, that means this capability is turned off here. It is 1 means it is turned on here. That's the only difference. Now, what this does, this gives us a capability to recover from a failed or a terminated or a kill transactions very, very fast. So as you saw a few seconds back, I started a transaction on both. What the transaction I started here is actually I'm trying to update my table to set a column, but I forgot and actually I made a mistake and uncommented the where clause, which means while my intention was to change only a few rows, I'm actually changing the whole table. And you can see this is a not a small table, it's a 20 billion rows table. So I realized my mistake and then I said, I need to stop this transaction. Now you can see this is canceling the query. This is doing canceling the query and it will go on for a while because it has to roll back the huge transaction on such a big table. Now on the right side, I have done the same mistake, and what I'm going to do is that I'm going to kill the transaction, and it comes back right then and there instantaneously. That's the magic of this capability. That's the magic of this capability to accelerate database recovery on. We introduce this capability, as you can see, this is still going on. It will go on for a while. We introduced this capability for hyperscale databases because we knew that these are big databases. They will have lots of tables with a large number of rows. And if somebody does a mistake like that, how to recover quickly. So now you see that with this capability on, we are able to do that. Now, every single SQL database, whether it's a hyperscale database or not a hyperscale database, is turned on with this feature by default. You cannot turn it off. For on-premises, you have this capability available in SQL Server 2019 and later. You can actually turn on and off. But for Azure, it is always turned on all the time. You cannot turn off. I had to actually take one from our development team to show you the difference, what it makes to be able to the impact of this feature. So you saw how Azure SQL database can handle canceling and recovery from large transactions. Now, I keep hearing from many of my friends and colleagues across the industry, um, what will happen to the role of the DBAs with all this automation happening behind the scene, all these capabilities of Azure SQL database coming in. Are the DBA's role going away? Not anytime soon, not really. The DBAs are always important to any database, whether it's a cloud database, whether it's an on-premise database. And in cloud also, they have responsibility to do. Now, if you're a DBA, Azure SQL database is the best database for you because here it is. This is a pyramid of various database responsibilities of a DBA, from installing, patching, and upgrading to thinking about strategy, future, doing performance tuning, designing, lifecycle, etc., etc. For a non-PaaS database, if the database was not Azure SQL database, then you will have to do all this stuff for yourself. You have to install patching. If that is your main job, designing the storage, designing the capacity, thinking about where my backups will go, thinking about when I'm going to patch it. If that is your full-time job as a DBA, uh, then you need to rethink, then you need to evolve yourself to do higher order jobs. As you go top to the pyramid, this is also makes your job more interesting. Performance tuning is a much more interesting job than installing or patching. Ask any DBA. So as a DBA, your job will be more of doing performance tuning, thinking about data lifecycle, thinking about strategy, future direction for your organization, rather than thinking of where do I put my patch, where do I install, where do I do my upgrades, because those are all taken care for you. How do I do my HA? HA is all taken care for you. Will this security capability be here? They are all built in for you. So you don't have to think about the uh, basic necessities of a database. You're thinking about the advanced data necessities of a database and a database application. And guess what? The higher you go in the pyramid, you bring more value to the organization. So if you're a DBA and you move up the value chain for your organization, then you got to think about the higher order attributes. And therefore, it enriches your job as a DBA. It makes your job more interesting, more fulfilling. So DBAs, you're all good with Azure SQL database. I keep this question, hearing this question from many startup companies. I'm a startup. Why should I use Azure SQL database? A lot of times, startups get attracted towards open source or other type of databases. They think that those databases are either probably more friendly for startup for whatever reason. But let me debunk that myth today. Because Azure SQL database comes packed with battery included, it packed come with so many rich features. What it does to you as a startup gives you a faster time to market for your application, because you can build complex application in a much faster, and you can deploy with rest assured that I don't have to think about my infrastructure. I do not have to think about my scale. I do not have to think about the tons of security things that I need, and thereby you will be able to bring your application from your startup to the market faster than if you're using any other database which is not as capable, or any other database where you have to manage your infrastructure, or any other database where the rich capabilities that I just discussed, from JSON to graph to geospatial to in-memory OLTP to column store, being able to serve an IoT application, being able to serve a graph application. All this is possible within Azure SQL database without you need to think about any other data store. And therefore, if you are a startup, Azure SQL database should be your first choice. In fact, many startups use it today. I'll tell you one startup, give an example. This startup company is building a blockchain application, and they use a development tool called Cora. Cora is a tool and language used by many blockchain application users, and that comes with a default database of choice called H2. And this company actually removed H2 and replaced that with Azure SQL database. Guess why? Because Azure SQL database has the security features that they need to build this blockchain application. They're building this blockchain application for a bank. Now, banks need high security. Banks need a lot of advanced security features like always encrypted, transparent data encryption, etc., etc. To achieve those, they replaced the default database that comes with Cora and started using Azure SQL database with their startup company. Now, you can think about many such examples, and therefore, rest assured that you'll be able to bring your application from the startup to the market much faster than anybody who is not using Azure SQL database. And so, with all this, how does the future of cloud relational database, specifically how the future of Azure SQL database looks like? It is bright, of course, and it is brighter than any other data storage technology that are in the market today, and it is the brightest it has ever been. So, if you have bet your career, your application, your business on Azure SQL database, you have bet on the right technology. With that, we come to a closer. Before we actually close, I want to give you a few learning paths. Recently, we have just published two books, Azure SQL Revealed and Practical Azure SQL Database for Modern Developers. And these books are available today on Amazon. They're available on Safari Books Online. They're available from Apress. And then you'll be able to gain tons of knowledge about this. And if you're a beginner, I would strongly encourage you to use these videos, the links that we have provided on the left from the product team, where we have a series of videos to ramp you up on Azure SQL database technology. Thank you, our sponsors, and thank you for all the organizers. And with that, we come to a conclusion. And please follow the guidelines given here. You can win a prize. And if you use Azure SQL database, you already have won a prize. Bye.